All right, this is Chemistry, Unit 10, Electron Bonding and Shapes, Part 2. This will be about our covalent bonding. Okay, Part 1 was about our ionic bonding. So remember, covalent bonds are ones where there's a shared pair of electrons, and they're typically between two elements, and those elements are typically two nonmetals. So it's often between two nonmetals. It means if we have a single covalent bond, that means that two atoms are just going to share a single pair of electrons, which will just be two electrons shared between them. So these two, one would come from this hydrogen and one would come from this hydrogen, and this would now be shared so that this has two electrons and this would have two electrons. And then if we have a double covalent bond, that would mean that there's two atoms are going to share two pairs of electrons. So that would mean these two were shared and these two were shared. So that would be 4 electrons are shared amongst them. So that would be, now that this oxygen has 2, 4, and then 6 and 8. So it has 8 electrons. And then this oxygen has 2, 4, 6, 8. So both of them, because they're sharing 4, would now have 8 electrons. And then we have something called a triple covalent bond, and that's when two atoms share 3 pairs of electrons. So they're actually sharing 6 electrons. So this would be 2, 4, 6, and this would be 8 for this nitrogen. And this would be 2, 4, 6, and this would be 8 for this nitrogen. Now lots of times, instead of using the 2 dots, I like to just use lines, okay? So Lewis dot structures can be really helpful in representing these covalent bonds between elements. So if I have, again, the 2 hydrogens, that would be those 2 electrons are shared, and so I show a shared pair just as a single line between them. So that line represents a covalent bond, and that line represents 2 electrons. Okay, then if I do the same thing for chlorine here, they're going to share 1 electron each, so that's going to make it where there's a shared pair like right in the middle, and so now that's going to be changed to a line. And then if I have oxygen, they're going to share 2 pairs of electrons, or 4 electrons overall, so I would draw it as 2 lines. Okay, so that makes it really simple and clean when we do that type of a diagram. We have nitrogen. Nitrogen actually shares, again, 3, because I used it as our example in the previous slide as a triple covalent bond. So if it shares 3 pairs of electrons, or 6 electrons total, then I can just draw it as 3 lines. It makes it nice and clean. And then these electrons, where they're 2 dots together, are called lone pairs. Okay, so this one has 3 lone pairs on it and a single covalent bond. This one has 2 lone pairs on it and a double covalent bond. This one has 1 lone pair on it and a triple covalent bond. So rules for writing electron dot structures: 1, use a pencil, and you're going to always add up all the valence electrons from all the atoms in the compound. Don't try to keep track of which element or which electrons come from which atom. Just figure out the total number of electrons. If you're working with an ion, you're going to have to add or subtract electrons to account for the charge. But I will tell you, we are pretty nice and we give you atoms for the most part. So for example, like on H2O, hydrogen has 1 valence electron and oxygen has 6 valence electrons. But hydrogen has 2 atoms here. So because it has 2 atoms and 1 valence electron, that would mean that it has 2 times 1 electron. And we have 1 oxygen that has 6 valence electrons. So that would be 2 times 1 is 2, and 1 times 6 is 6. So 2 plus 6 is 8. So this would mean in this compound we have 8 valence electrons to work with. Number 2, put the element that you have the fewest of as the central atom. So then after you put the fewest in the middle, you'll put the other elements in spatial order around it. So like for H2O, I have 2 hydrogens and 1 oxygen. So that single oxygen is the one that I have the fewest of. So it will go in the middle. And then I'll put the hydrogens on either side. So since oxygen is my fewest, it goes in the middle, and then I put my hydrogens on either side. That's step 2. Now step 3, use a pair of electrons to form a bond between each pair of atoms. So again, just draw the bonds. So we'll do a line drawn there to show that bond, and a line drawn there to show that bond. So that's step 3. Step 4, now use other electrons to either satisfy the duet rule for hydrogen or the octet rule for any of the other atoms. So with this, I already have 2 around the hydrogen because of that covalent bond, so it's good to go. And I have 2 around this other hydrogen on the other side because of that bond, so that's good to go. But oxygen only has 4 around it, and it needs 8. So I have to add an additional 4 to my oxygen so that it has 8. So once you've satisfied the octet and duet rule for everybody, now you're good to move on to step 5. Now step 5 is to count your number of electrons represented in the molecule. If you have too many electrons represented, you're going to draw a double bond between the 2 elements and remove a pair of electrons from each element that's taking part in the bond. Okay? For this one, we have 1, 2, 3, 4, 5, 6, 7, 8. If you remember, our original count said that we could only have 8 electrons. So this is correct, and I don't have too many. Okay? So everything's good to go. So, CH4. First of all, count the number of valence electrons. Carbon has 4, hydrogen has 1, but there's 4 atoms of carbon, or of hydrogen, sorry. So, 1 times 4, and 4 times 1 is 8 electrons. 2, draw it spatially. The one with the fewest is carbon, so it goes in the center, and then arrange the hydrogens around it. Step 3, draw covalent bonds between the elements. So we draw bonds. Step 4, octet rule. So do the hydrogens have 2? Yes, each one of those lines represent 2 for the hydrogens. And does the carbon have 8? Well, because the carbon's in the middle and it has 4 lines shared, that's 8. So yes, the octet rule is satisfied. Then, step 5, count the number of electrons. So 2, 4, 6, 8 because of the bonds. So does that match the number of valence electrons I said in 1? Yes, it does. And that would be my diagram. All right. CO2. Carbon has 4. Oxygen has 6. So 1 times 4 and 2 times 6 gives me 16 electrons. 2. Spatial order, the one with the fewest is carbon. So carbon goes in the middle, and we space oxygen on either side. 3, draw the bonds. So we draw a single bond between each. Then 4, the octet rule. So oxygen only has 2. It needs 6 around it to make 8. So we're going to put 6 dots. Carbon had 4, so it needs 4 dots around it so that it could have 8. Now, that satisfies the octet rule. But now we have to count the number of electrons. And when we count the number of electrons, we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Well, that's way too many because we're only allowed 16. So we're going to have to erase some. And when we erase some, we're going to make a double bond between here and here. And we're going to erase 2 from this one and 2 from this one when we do that. And then we're going to make a double bond here, and we're going to erase 2 from this one and 2 from this one, because whichever elements are involved are the ones where we erase the double bonds, or erase the electrons from. So we'll erase electrons there, and we'll erase electrons there. Then we need to recount. Now we have 2, 4, 6, 8, 10, 12, 14, 16. So yes, we do have the correct number of electrons, and we match how many we were supposed to have of 16, so we are good to go, and that picture is correct. All right. The next one, NH3. N has 5, H has 1. There are 3 hydrogens, so 5 plus 3 is 8. Spatial order, the smallest one is nitrogen. It goes in the middle, and you arrange the hydrogens around it. Step 3, draw the bonds. Step 4, the octet rule, or the duet rule. Hydrogen has 2, hydrogen has 2, hydrogen has 2. Nitrogen only has 6, so we have to add 2 dots to make it 8. So that satisfies the octet rule. Now we count our electrons, 2, 4, 6, 8. Yes, that matches our number of valence electrons, so we are good to go. Our next example, CCl4. Carbon has 4 valence electrons, chlorine has 7. So 4 plus 28 is 32 electrons. So we have to do spatial order. The smallest one is carbon, so it goes in the center, and we space the others around it. 3, draw your bonds. 3, 4, between the elements and the central atom. And then octet rule. Okay, well, carbon has 2, 4, 6, 8. It's good. Chlorine only has 2, so it needs an additional 6 added to every one of them. So that's satisfied. Now we have 2, 4, 6, 8 around each chlorine, and we have 4 chlorines. 8 times 4 is 32, so the number of electrons matches as well, and we are done with the compound. All right, or the drawing. So that completes our covalent bonding. If you have any questions, there's practice in the classwork and on the homework. If you have any questions, please let me know.